Good morning, everyone. My name is Zhuo, the Chief Technical Researcher of Huawei Storage from the Zurich Research Center. Today, it is my great honor to stand here and share with you the latest innovation of the next generation of storage system from the technical perspective. Over the past 30 years, the development of the data application has driven the continued growth and innovation in the data storage industry. From database, file system, virtualization, up to big data, distributed database, AI, and edge. The unstructured data has become the main stage of the explosive data growth, and the data value is increasingly important to customers. And the requirement of data resilience has also evolved from preventing nature cost, physical device-level failure, to the defending against the human cost data failure, such as ransomware attack. So we can see the new applications, new data, and new resilience will be the driving force for continuous innovation in data storage technology. As we know, the capacity, the performance, and the reliability are always the three most critical properties of the storage system. In response to the rapid digital transformation of enterprise, storage innovation will expand beyond the basic dimensions of capacity, performance, and reliability, integrating the energy efficiency, the resilience, and multi-cloud ecosystem. We propose the 6 technology directions for innovations, and I will introduce these technologies. Okay, the first one is an evolution of advanced storage medium, which is always a core component of storage system. In the future, the hybrid workload of new applications, SSD will be the most dominant storage medium due to the advantage of the performance, ease of management, and energy efficiency. And more data need to be analyzed and processed online in real time. So how to leverage the value of the data better? The storage medium for the hot data will evolve into memory semantic. Yes, the memory semantic medium, not only the memory, okay? The memory semantic interface is friendly for the in-storage data processing. And I think the tiered memory architecture makes it possible for the large scale, the large capacity memory. On the other hand, the huge number of the unstructured data generated by all the world need to be long-term, reliably, and economically stored. We think the Blu-ray is one of the available evolution for the cold data. So in summary, the memory semantic medium for the hot data, and all flash for the warm, and the Blu-ray for the cold data. So the next one is the innovation in the architecture level. The modern application like AI and big data and so on are typically computing intensive and data intensive, which has higher requirement on performance and energy efficiency. The CPU-centric architecture will gradually become the bottleneck for the performance and energy efficiency. So in the future, the infrastructure architecture will evolve into data-centric and composable. Macroscopically, the pooling of the computing units, the memory, the storage, will significantly increase the resource utilization efficiency. Increase the resource utilization efficiency, and the shared memory pool will eliminate the cost of the useless data movement. And the high throughput, low latency memory semantic networks, just like the CXL, makes the memory-centric, composable architecture possible. And microscopically, the technologies such as in networking computing, the DPU, the processing in memory, and the computational SSD are used to converge the capability of computing, networking, and storage. And it to effectively improve the data processing efficiency, leveraging the most suitable heterogeneous computational components rather than a general purpose CPU. And in the new architecture, I think the traditional I/O-based data stack will be redefined and simplified. And the next generation storage system with the new data paradigm will provide a more friendly service, will provide the more friendly and directly service to applications by the memory semantic data processing interface. And the next one is something about innovation about the data service. And the next generation storage system is required to support cross data center and cross cloud data tiering, and the global data management and the container storage to eliminate the data silos by the global data insight, by the global data view, and the global data scheduling. The storage system can achieve the data collaboration across multi centers. Moreover, the storage system will act an accelerating engine to emerging applications by providing the application-oriented storage interface and service, which is supporting the new data format, the new data structure, the new data paradigm, and in storage data processing operations and functions. For example, the accelerating engine for big data will provide the table semantic data format and operations, and the acceleration engine for AI will provide the feature store to support the large embedding tables and approximate search in inference. So I think we will have a lot of the same interest with Professor Wolfgang. Therefore, the next generation storage system will evolve from providing the traditional storage service into providing data service that is very important, horizontally to support the global multi-cloud data collaboration, and vertically to support the data processing acceleration for emerging applications. Okay, let's move on to the innovation on data resilience. Nowadays, as becoming the core property of the modern enterprise, the data itself is facing threat from not only nature cost, the hardware failure like earthquakes, and also human cost attack like a ransomware attack. Therefore, I think it would be much necessary to build a comprehensive data resilience mechanism around the whole life cycle of data. The next generation storage will provide the capability of native data resilience at all the stages of data life cycle, from the data generation, the data transferring, the data storage, to the data usage, the provisioning, sharing, and the destruction. There are a lot of innovative technologies in this direction. For example, the QKG, the algorithm of quantum key distribution for the anti-quantum attack in the data transferring. And another technology is about innovative computational SSD, integrated the native data resilience, the native anti-tampering, leveraging the features of the SSD's appending right. And another interesting topic is autonomous storage. As we know, the AI for storage is a very active technical directions in the current storage innovation. And with reference to autonomous cars, we also proposed the concept and the stage definition of autonomous storage in the next generation. In this figure, we grade the degree of automation of storage system in management and the device, and in management and device dimensions from level 1 to level 5. Intelligent storage management, including the operations, the maintenance, and the system optimization. Its intelligence degree, I think, represents the degree of the easy to management of a storage system. And the intelligent storage device, we focus on the performance and the reliability dimension, which represents the capability of storage system how to self-learning and self-tuning for the high performance and self-healing for the high reliability. The current storage system is generally standing between level 2 and level 3. That is partial autonomous. And we hope the next generation storage system can achieve the level 3 and evolve into level 4. To reach the level 3, we need breakthrough series of technologies. For example, in the management dimension, we have to break through the automatic failure prediction and the automatic the root cause location. For example, using the algorithm of knowledge graph. And in the device dimension, for example, for the on-tuning, the self-tuning performance, the storage system need to build a capability to the I/O pattern self-learning and the modeling from the internal and external information of the storage system, and then self-tuning the performance by adaptive configuring the key parameters in the storage system. For example, the algorithm and strategy of the cache prediction, the cache allocation. And next one, with the increasing popularity of emerging applications such as AI, big data, and supercomputing, the power consumption of data centers has increased significantly and is gradually becoming a core challenge for the enterprise. As an important infrastructure of the data center, the green and the low carbon of storage is an also important technology point to be considered for the next generation. So storage needs to be designed considering from the production, from the hardware level, the software and system level, and the algorithm. In the system architecture level, the heterogeneous computational components, including DPU, including the computational SSD, and the other dedicated accelerators, will be broadly used, deployed in the system instead of the general purpose of CPU, significantly to improve the energy efficiency. So that means let the suitable guy to finish the suitable jobs. In addition, the algorithm of data reduction is also important. For example, the cross data center global data duplication helps the storage system not only reduce the data capacity stored in the median, and also reduce the data transferred in the network between data centers. So that is also a great benefit for the networking. After introducing the technological innovations of next generations, I want to say the innovation is always not easy. The innovation processing requires the close cooperation of industry and academia. from the theoretical breakthroughs, technical inventions, technical prototyping, and the technical engineering. So in the future, Huawei is actively working on different innovation models, cooperating with universities and research institutions to jointly to solve the storage challenges, promote the storage industry innovation and development, and achieve the win-win cooperation. So next, let's watch a video about the Huawei Olympus Mons Award, please.
The Olympus Mons, located on planet Mars, stands at 21,000 meters, making it the highest mountain in the solar system. The Olympus Mons Awards encourage us to solve storage challenges to build data infrastructure faster and better. We hope that researchers around the world will join us in finding the answers to these challenges.
I'm very honored to win the Olympus Mons Award for 2022. This award is not just a recognition of what has been done, but hopefully it will enable a lot of other things that will be very useful for the wide industry. So I believe going into the future, computing systems will evolve in a way that incorporates a lot more computation and memory together, and more analog computational capabilities and memory as well.
The Olympus Mons Award is focused on storage performance. But as we see, it is also now critical to the future of computing performance.
Okay, I think you have learned a lot about the Olympic Mons Award after watching this video. So please allow me to take some additional information. The Olympic Mons Award is open to universities and scientific research institutions around the world. It set up 2 challenges, with each one with a breakthrough prize of 1 million RMB. So in the previous video, we are glad to see the Professor Onumutlu from the ETH Zurich has won the award, the big award of the 2022. And next, I'd like to take today's opportunities to introduce the challenges for Olympus Mons Award 2023. So the 2023, the Olympus Mons Award also has 2 challenges, 2 big challenges. The first one is storage with ultimate per bit cost efficiency with 2 directions: innovative data-centric architecture, existing and new media innovation, how to improve the per bit cost efficiency on the architecture level and the media level. And the second challenge is data resilience and service oriented toward multi-cloud environments. It's also including the 2 directions: efficient data storage and management for new applications, and data resilience and proactive protection. So we sincerely invite all the university and the scientific research institutions around the world to join to solving the technical problems and unleashing the data value and contributing to digital civilization. Okay, that's all for my presentation. Great thanks for your listening. And before I finish my topic, please allow me to share one more thing. The global data compression competition, GDCC for short, co-hosted by the Autonomous University of Barcelona and Huawei. So now let's warmly welcome the Professor Juan Serra Sagrista from the Autonomous University of Barcelona to introduce the GDCC. Welcome, Professor.